And also, let me share with you the question that we had last time. So last time we had this kind of question. I don't know whether you can see clearly there. I try to zoom in there very well. That's the question that we had. For Wendy, I don't think you attended that lesson, but the question that you are seeing in 1998, that's the question that I left with your friends. And you were required to find the answers. So without wasting time, what I'm going to do is I'm going to copy the question very fast, and then we go through it and then see. Now, the answers that I received, the first answer was from Alexandria, who is offline. The other one was not the answer, but it was someone needed help. But at the end, I asked, how can I help someone who had no working? So at least when you are asking for working, show me what you have done, and then afterwards, I can help you from there. So the problem was that that person did not have the what? Did not have the working. And it was a bit hard for me to explain in space without seeing what.
Teacher.
Was that Cynthia?
Yes.
Yes, Cynthia. And then afterwards, I needed to see what you had done. It would work out very well. Huh? Yes.
Okay.
Yes. Even if it is disorganized, what you show me. Huh? Then afterwards, I tell you, this is what you're supposed to do. This is what you're supposed to do. And the next time, be neat.
Okay.
Yes. So when we are learning, do not get afraid of failing. That is the first thing. When you are learning, do not get afraid of failing, because it is from the mistakes that we make, and then we keep on smoothening. Then afterwards, we become masters in what we are doing. We become masters in what we are doing. So never fear to do something because you expect failure. Okay, even if in daily life, never fear something. Go ahead and do it, whatever the outcome may be. Then you'll be learning. At the end, you know that if I do this and this, I'll get this. Then that's the main thing. Then you'll be mastering. So always perfection comes from the repeatedly actions that we keep on doing. That's when you can master something. So this was the figure, and these were 12 centimeters. And they were telling you that the figure AB, ABC, ABC, FG, H, A, B, C, D, E, F, G, H. So that is the figure. And with this figure, they are telling you that AB, sorry, they're saying that it has square ends, B, C, D, F, and A, D, H, E of side 12 centimeters. So it means that if this was 12 centimeters, it means that also this one is 12 centimeters. Also the other side is the same thing, 12 centimeters. Inside here, it is also 12 centimeters. So they are saying that AB is 16 centimeters. Then calculate part A, the length BD and BH. So I'll first take away this so that I don't know whether you have taken a snapshot of that. But in the previous video, when you go and watch the previous video, you'll be able to see exactly what we are talking about. This video, if you watch this, there's this video here, which is here, 3D revision part 2, this one here. You'll be able to see that part, that question. Okay, so let us find the length. Let us find the length BD, the length BD. So the length BD is the distance from B to D. So we are going to use our ruler and we draw that distance. So we shall use dotted lines. Okay. So that is BD. Now what we should know is that in the corners we have 90 degrees. So here we have 90 degrees. And also here we have 90 degrees. Also the same thing here, 90 degrees, 90 degrees. So it means that we have a right angled triangle. We have this one, ADB, and we also have DBD, DBC, DBC. That is also a right angled triangle. So we can use that right angled triangle and we find the length BD. So to do that, you have to be organized. So to do that, what I will do is that I'll come and I draw the right angled triangle. And then I put 90 degrees here. Now you ask yourself, where is 90 degrees? We are on BD. Where is 90 degrees? 90 degrees is at point what? If I'm using this triangle, BCD is at point C. So I'll put point C here. Are we together? So that point C is here. And then I'll put point B here. Then I'll put point D somewhere there. Then I'm looking for BD. BD is this one here, which is the hypotenuse of that triangle. So I know BC is 12 centi. 12 centi. And then DC is 16 centi. So I'll come and say BD squared equals to CB squared plus DC squared. So BD squared equals to CB squared, which is 12 squared plus 16 squared. So when you are using a calculator from there, you get BD squared, which is equal to 144 plus 16 squared is 256. So 144 plus 256 is
400.
Get 400. So it's equal to BD squared. Now you go ahead and find the square root on both sides, and you have BD equals to 20 centimeters. And that is our answer for BD. That's the
BD.
That's the answer for BD. Okay, answer for BD. Now, the next thing is to find the B what? BH.
BH.
We are going to find the BH. So let us see what BH is. Okay. So now, BH is from B to H. So what we are going to do is we are going to draw a line from B to H. Are we together, members?
Yes.
Okay, so we draw a dotted line from B to H. Now, I want you to look very closely. That you should know that at this point here, which angle is between the line DH and DB? Which angle is there? Let me ask you again. Which angle is between the line DH and DB? Which angle?
It's 90 degrees.
It is 90 degrees. So at this point here, we have 90 degrees because this is the base, and this base makes 90 degrees with this line. So it means that since this line is on the base, so it means that the angle between this line and the line which is on the base is 90 degrees. Okay, so what we are going to do is we are going to use triangle. So we are going to use triangle. We are going to use the triangle, triangle HD, HDB.
HDB.
That's the triangle we are going to use. So let us see. So I will draw a triangle HDB. Now, you ask yourself, where is 90 degrees? If we look so closely there, you can see that 90 degrees is at point what? At point D. It is at point D. So I'll put my 90 degrees at point D. So at D here, that's where I'll put. That's where the 90 degrees are. And then, when you look closely, we have the height. So if this is point D, if this one is point D, this one here, if this one is point D, then it means that this point which is here, H, this one here, this is D, so it means that this one is going to be H here. So I'm going to put my H here, and then I'll put the B, yes, the B here. Such that the BH is the hypotenuse. Now I'm going to fill in. What is DH?
12 centimeters.
It is 12 centimeters. DH is 12 centimeters. Since GC, SIG or GC is 12, that means also DH. So I'll put here 12 centimeters. And DB we found it is 20 centimeters.
It's 20 centimeters.
Okay. So members, the next thing is what we are going to do is to find BH by using Pythagoras theorem. And we shall say BH squared is equal to DH squared plus DB squared. Are we together?
No.
Are we together? Members, are we together? Members, are we together? Do you hear me? Members, are you hearing me?
Patricia.
Members, are you hearing me?
His connection is wow.
He's back.
Are you hearing me?
Yes.
You are getting me where?
Mm-hmm.
Yes?
Yes.
Okay, sorry. There was interruption with this network. So let us proceed and find BH. So BH squared will be equal to DH squared, which is 12 squared, then plus BD, which is 20 squared. So we shall have 144 plus
400.
And we shall get 144 plus
500. 544.
500 and what?
44.
544. So you can find the square root on both sides, and our BH is equal to
23.
23.3.
3.3 centimeters.
Centimeters.
Okay, so that is the pH. Now we go to part C. Patricia, did you pass part C? Yeah? Alexandria, are you the one who did part A? And you passed this one, then I told you to do part B. I told you for you to do part B, you must first find pH. So let us see what was in part B. Then afterwards, we shall go to part C. Okay. Now, the question is telling us that when you look at part B, it's telling you that find the angle between the line. Wendy, are we together?
Yes.
Okay. It's telling you that find the angle between the line BH and the plane ABCD. So what we are going to do is we are going to find the angle between the line BH, which I've just drawn, and also we find the angle between this line and the plane. So the plane is the base which they are talking about. So let us draw the diagram. Let us go to the diagram and see what they want. So they want us to get the angle between BH and plane ABCD. That's what they want. So for us to do that, excuse me for that. So what we are going to do is we are going to determine where is that angle located. So let us look closely in this diagram here. Look closely. My camera is blank. Okay, I think there. Now I want us to look so closely here. So this is the line BH. This is the line BH. Okay. And this is the base A, B, C, D. So the angle they want is the angle between this. This is the angle they want. I don't know whether you can see it there. That's the angle they want inside there. So it means that for us to determine the angle between the line and the plane, we have to bisect that plane along that line BD. So you see the line BD, this is the line BD. And the line BD is on the plane A, B, C, and D. This line BD that we found. So it means that we are going to use this triangle exactly that we have already drawn. This one here. This triangle is what you want to find. So the angle they want us to get is the angle at point B. You can see at point B here, this is the angle here. So this angle is between BD, this was BD here, and then BH. This is BH. So this is the BH, and this other one is the BD. So the angle between BD and BH will be the angle between BH and the base. Why have we chosen BD? Because BD is on the plane A, B, C, D. You can see BD is the one which is on that plane. So the angle that will be in between those two lines is the angle between the plane and the line BH. So since you already used the triangle HDB, so this means that we want to get only this angle here that you are seeing. That's the angle we want to get. Members, are we together? Yes? Are you there?
Yes.
Yes. So this is the angle that you want to get. This angle which is here.
This angle which is here.
Because BD is on the base.
Because BD is on the base.
The base A, B, C, and D.
Which one?
Okay, let us find that angle. So that angle is at point B, somewhere here. This is point B, so that angle is here. So we are going to use AD, HDB. So when we come back to our diagram here, you can see this is HDB. So the angle they want is this angle which is here. That's the angle that they want between BD and BH. So we shall call this one theta. So for us to find that angle theta, what we shall do is we shall say tan theta equals to the opposite over the
Adjacent.
Then tan theta equals to 12 divided by what? 20 divided by 20. Okay. So it means that theta equals to the tan inverse of 12 out of 20. 12 out of 20. So what do you get as theta?
30.96 degrees.
What do you get, members?
30.96.
You get 20.1?
30.9.
0.9.
6 centimeters.
0.96 degrees.
Yes.
So you can round it off and it becomes 31. 31 what?
31.
31
31 degrees.
31 degrees. So that's the angle between BH and the plane ABC and D. Okay. Now people are waiting for part C. People are waiting for part C. So you can let us see what part C was. Okay, so part C was saying that find the angle between the planes CFH and BCDF. Okay, let me write that. Angle between planes CFH and BCDF. Okay, so let us look closely on this diagram, to this diagram here, which is here. I'm going to look very closely and see what is the plane CFH. Now, this is C. This one is C. Where is F? This is F, and H is here. Are we together? This is F.
No.
This is C, F, and H. Those are the points. Are you seeing them?
No.
No.
You are not seeing.
No.
Are you seeing now?
Yeah, we are seeing.
So this is C, this is F, and this is H. Are we together? So
Yes.
we are going to draw a plane. We are going to draw a plane there and see how that plane is. So there, let me use a pencil and see how that plane is.
Jacob ruler.
That is the plane members. Okay, CFH. This plane. If you want, I can shade it for you to see it very well. That's the plane there. Now they are telling you to find the angle between this plane and BCGF. BCGF. So in other words, what we are going to do is we have to find the center here. The center here. And now we bisect this plane into two. So we are going to draw a dotted line from here, because we have to bisect this one into two. Okay, like that. So we have bisected that one into two. Okay. Now we need also to bisect. We are going to bisect CFD into two. Why? Because when you look at this plane, this one here, BCGF, for us to get the angle in between, we must bisect these two planes to get this first plane and also the second plane, such that their lines meet at a common point here. And at this point, that's where we have the angle. So I'm going to bisect the plane BCGF. Like that. So it means that the angle that we want is this angle, which is here, this one here, this one here. That's the angle we want. So we shall call this angle theta. Are we together? Members, are you there?
We are there.
So for us to find this angle theta, we should know that at this point here, this is 90 degrees. This line and this line, they are meeting at 90 degrees. So here we have 90 degrees. There we have 90 degrees. So we have to get this distance, but this distance is 16 centimeters, isn't it? Members, are we together?
Yes.
So what we need to do is we need to find this distance here, this distance. We need to find that distance such that we use this triangle here. I don't know whether you are seeing. We use this triangle here. This triangle. So we are going to be using triangle. If I call this one point, let me call it point P. Okay, then we are going to use the triangle PGH to find this angle here. Which they want. So for us to find PG, we must first find BG first. So we are going to first find BG by using BCG and we find BG. Now we're going to divide BG by 2 and we find PG. Once we find PG, then we can use PG and GH using trigonometry and we find the angle theta. So let us do that. So the first thing we are going to first determine BG. We're going to first determine BG. Okay. So for me to find BG, I need to first do that triangle BCG. So this is triangle BCG. So this is B, this is B, this is C, and this is D. Okay. Now my point P is somewhere here. That's where my point P. But let me fill in this. This is 12 centimeters and this is 12 centimeters. So for me to get big E, I will say big E squared equals to BC squared plus CB squared. Then big E squared will be equal to 12 squared plus 12 squared. So this is 144 plus 144. Members, are we together?
Your screen is over freezing.
My screen is freezing.
No.
Yes.
It's your network, my dear.
Teacher, no,
Sorry.
my network is very
Oh, okay, you add it for me. 144 plus 144. Your network is very what?
Yeah, my network has no problem.
Okay. So what do you get as big E?
288.
So the square root of 288.
16.
16.97. Yeah?
7.
Yeah, 16.
Yes.
16.97 centimeters. So can we get Piggy? Can we get Piggy and Piggy? What is Piggy now? Piggy is equal to, we want to get Piggy, but this is the middle part of Biggie. So Piggy is equal to a half what?
Piggy.
A half BG. Okay. Okay. So this gives us a half times 16.97. And what do we get? We get 8 point what? 8.5, isn't it? Members, are we together?
Yes, teacher.
We get 8.5. Are we together?
Yes.
Okay, so now what we are going to do is to find this angle. How do we find that angle? Theta, this one here.
This one here.
This angle theta here. So we are going to use the triangle PGH. PGH, and we find the angle theta. That angle. So I'm going to draw the triangle PGH. Yes.
Yes.
Yeah, I thought we are finding this FC. Then we find FP.
FC, then we find the FP, and then
Because the triangle is FC. FC something.
this is Patricia.
Sir, please scroll down.
Sorry?
No,
Okay.
it's Esther.
So Esther, you are going to ask me again in the next session, because we are left with only seconds for this session to end. Okay?
Yes.
Yes.